Okay, welcome back to the next module of the Coding Club. In this module, what I'd like to do is try to go over some ways in Python that we can calculate mass based on various sorts of parameters, things like amino acid sequence or RNA sequence, or hopefully we'll get to things like atomic formula and smiles and things like that. But in this first video, we're going to really focus just on how would we calculate the mass based on this amino acid sequence. So I pasted in here the amino acid sequence of my favorite protein. This is the nanodisk scaffold protein, MSP1D1. I just pulled this off of the Sigma website, so I just copy pasted this in. You'll see I put a little slash here just to knock this down so it was all in one line. Otherwise, what you would see is something like this. But if you just put this here, another way to do it is put it in those parentheses. The first thing we need to do is now have a dictionary that can encode all of these different letters as their mass values. And so I'm just going to paste this in. I created this separately. It would be painstaking to calculate all of this from the web, but I'm just going to put this in here. So this is a structure called a dictionary. Dictionaries in Python are outlined by these curvy brackets on the outside. And then you have two elements. You have a key, in this case, A, C, D, E, etc. And then you have a colon that specifies that, that differentiates the key and the value, and then you have the value, right? So the value comes after the key. In this case, the value is all of the different average masses for all of these different amino acids. And so to use a dictionary, the way this works, we could do print AA masses dot keys or something like that. Then you could see, I'll go ahead and run this. You can see these are all the different keys. You can print the values, right? Those will show you all the different values. This is now as like an array or a list. But what you would do to actually call one of these is you would just say A, right? So you would say A masses of A, and what it spits out is this value. So you feed in the key and it spits out the value. So if we were to put in an H here, we would get 137. If we put in a T, we're going to get 101, right? So now to make, what we could do is write a for loop, right? So we could say like mass equals 0 and say for S in test seek mass AA equals AA masses of S, right? We'd say print S mass AA. If we do this, run it, you can see we're just looping through all of the different amino acids and all the different masses. So then, of course, we could just say masses plus equal mass AA. And then at the end, do print masses. Right? So basically at the end, it would say this is what our mass is here. But there's actually a little bit more sophisticated way to do this that's going to be actually, for some reason in Python I don't understand, it's faster, but it's also easier to write. You could just say masses equals AA masses of S for S in test seek, right? So we're just putting this for loop inside of an array. And now what we're going to get, let's print that, is just a list of masses, right? These are all the amino acid masses. And then we can use NumPy, if we import our NumPy library, which you'll remember from last time. Import NumPy as NP to just sum all these together. So we could say total mass is numpy.sum masses, right? And then we could print our total mass. So let's go ahead and do that. Now this is not exactly the full total mass, and that's because what we printed is just the sum of all the amino acids, and we forgot the terminus. So instead what we need to now add is we need to add the mass of the water. So I'm going to go ahead, I have another variable here where I have the average mass of water. I'm going to put that there. So then we could say plus mass water, right? And now if we run it, that should give us the average mass that we'd expect. And that's right on for what I'd expect for this protein. It matches what we get in XPASI, right? So if we want, we can now start to feed some of this together into a function. So we could say define calc AA masses, or let's just say calc prot mass, right? And we'll put the sequence in there. Now let's go ahead and just put all of these things inside the function. So it's going to do that. And in fact, maybe what we'll do is instead of calculating an intermediate variable, we can just take this and put it in here and then say return. Right? And I'll reformat that so it looks a little bit prettier. And then we'll call the function calc prot mass test sequence. And then if we run it, we should get a nice value. Okay. So this gives you a basic idea of how to take a protein sequence and to calculate an overall mass for that protein. In the next version of this, in the next video, we're going to go into a little more depth, refine a few more of these parameters, because there's a couple things that this is not going to do, like catch errors. So I think what we'll go through in the next video is just how to make this into a little bit more sophisticated of a function and build in some new features. So with that, we'll see you in the next module. Thank you.